Hey everyone, so I'm going to take you through the full lesson number, I think it's 30, the second lesson for implicit differentiation. So pause the video and find the tangent line. So notice that is a circle. So the derivative is 2x plus 2y, and then dy dx, because remember, it's really a chain rule. Derivative at y is a function, equals derivative of 25 is 0. I'm going to solve for dy dx. So I subtract 2x and divide by 2y. So negative x over y. We're finding the tangent line at negative 3, 4. So that's negative 3 over 4. So my tangent line, y minus 4, equals 3 over 4, x plus 3. That's it. All right, so pause, go through, check your homework, make sure you got them right. If you have questions, you can email me or come see me. All right, so pause the video, try it on your own. All right, so we have the derivative of sine, so cosine of y times derivative of the inside. The inside is dy dx. Plus, now this is a product rule, x times y. Derivative of x is 1 times y plus x times the derivative of y, dy dx, equals derivative of x is 1. So now I have, this has a dy dx, this has a dy dx, so I'm going to do dy dx and factor out cosine of y plus x equals, this y has to go to the other side, so the right side becomes 1 minus y. And then finally we divide. So dy dx equals 1 minus y over cosine y plus x. Done. All right, I think we did this one in class, but this one's really not that bad. So pause again, try it. This looks hard because it's 1, 2, 3, 4, 5 different terms, but if you just take it one piece at a time, the derivative of x squared is 2x. The derivative of 4xy is a product rule. So 4y plus 4x dy dx plus 4y squared, so that's 8y times dy dx. And now 3x is minus 3, and then derivative of 6 is 0. So everything, and I actually do this on my paper a lot. You'll notice I keep circling things. So I circle everything that has a dy dx, and then I factor whatever's next to it. And then everything that's not circled goes to the other side. So I have 3 minus 2x minus 4y. Order doesn't matter. So 3 minus 2x minus 4y and divide by my parentheses. Right, so it's really actually pretty straightforward. I don't think this one's that hard. All right, very similar idea. So pause, take the derivative. This time we're going to find a tangent line though. All right, so I have 6x squared is 12x. I've got a product rule, so derivative of 3x is 3 times y plus 3x, derivative of y. 2y squared, so that's 4y dy dx. 17y is 17 times 1 times dy dx. 6 goes away, equals 0. So let's see, I have this one, and this one. So dy dx equals, or times 3x plus 3y plus 17 equals, I bring everything else to the other side and then divide. So negative 12x minus 3y over 3x plus 3y plus 17. So now I'm going to find the tangent line. So I'm going to plug in negative 1, 0. So let's see, that's 12 on top. The y goes away. -3, this y goes away, plus 17. So that's 12 over 14, 6 over 7. So then I can write my equation, y equals 6 over 7, x plus 1. All right, here's a hard one. You can do it, though. I have confidence in you. All right, derivative. Product rule. So derivative of the first times the second. So 1 times sine of 2y plus x times derivative of cosine. Sorry, derivative of sine is cosine. Leave the inside the same. Times the derivative of the inside. Derivative of 2y is 2 times dy dx. Equals. Now the right side. Again, it's a product rule. So the derivative of y is dy dx. Cosine 2x plus y times derivative of cosine is negative sine. Oops, running out of space. And then times the derivative of the inside is 2. Whew, this one's a little rough. All right, so this whole thing is all being multiplied. And then I have this, that's all being multiplied. So those two blue are, those two need to go on, I'm gonna move this over to this side. So and then I'm gonna move this to the other side. All right, that's gonna go over there. I know you like my arrows. So I get dy dx times, so let's see, I got cosine, I got this. So I'm gonna write that as 2x cosine of 2y. And then when I move this piece over, I get negative cosine of 2x. Whew. And then on the right side, we have, I'm gonna simplify this. So I get negative 2y sine of 2x minus sine of 2y. You can take multiple steps if you want. I just think it's easier for me personally to like just draw arrows and highlight and things like that. All right, so final answer. Oh no, this is not the final answer. This is just my derivative. (2x cosine of 2y minus cosine of 2x. Ugh, now we have to plug in. This is going to be a rough derivative. This is going to be rough. All right, I'm going to use black. All right, so I'm plugging in pi over 4, pi over 2. All right, so we get negative 2 pi over 2. Sine, I'm just going to write my answer. So this is sine of pi over 2, right? Because 2 times pi over 4, right? Sine of pi over 2 is 1, so it's 1, minus sine 2 times pi over 2. So sine of pi, which is 0, so that whole thing goes away. All right, cool. So that's my numerator. I'm just going to simplify it. Okay. Over 2x, so 2 pi over 4, cosine of 2 times pi over 2. So that's cosine of pi. Cosine of pi is negative 1 minus cosine of pi over 2. That's 0. So that also is 0. So this is our slope. So we get, let's see, the negatives go away. So I got pi on top and pi over 2 on the bottom. So the pi's cancel and we get 2. Wow, all that and our slope is 2? Seriously? Y minus pi over 2 equals 2 times x minus pi over 4. That problem's rough. This was hard. All right, second derivative. So we do our first derivative, 2y dy dx plus 2 dy dx equals 2. Factor out, so I'm solving for dy dx. I'll factor it, jk. So we get 2y plus 2 equals 2. So that's 2 over 2y plus 2. Now I'm going to simplify it. You don't have to. I'm going to divide everything by 1. Just because I feel like it's going to be easier later. All right, so now I have to take the second derivative. So the derivative of this. So now remember I told you to memorize the derivative of 1 over x? The derivative of 1 over x is negative 1 over x squared. So that means the second derivative here is negative 1 over y plus 1 squared times dy dx. The derivative of the inside. So that just made it easy. That's why I have you do that memorization. So now I'm going to substitute in negative 1 over y plus 1 squared times 1 over y plus 1. So if we want it, you can leave it like that, but if you simplify, you get negative 1 over y plus 1 to the third. And that's your final answer. Alrighty. Pause the video, try it on your own. I know it's a little gross because that is 5xy to the 2/3. That's an exponent. All right, so take your time with it. It's 2 product rules. So we got 5y to the 2/3 plus 5x times 2/3 y. 2/3 minus 1 is negative 1/3 times dy dx. Whew. All right, so now we're doing the second one. Be careful with this negative. That messes a lot of kids up. So think of it as negative x squared. So negative 2x y minus x squared, whoops, dy dx. That is not a plus, it is a minus because think of it as a negative x squared equals 0. All right, so now let's find our dy dx's. So this is one big term, and this is one term. So I'm left with dy dx times, okay, so I'm going to rewrite this. This is 5 times 2 is 10, so 10x over 3y to the 1/3 minus x squared equals, and then everything else moves to the other side, so the 2xy minus 5y to the 2/3. Then we divide 2xy minus 5y to the 2/3 over 10x over 3y to the 1/3 minus x squared. All right, so now I have the derivative. Now we're going to plug in to find our point, so 3, 8. So 2 times 3 times 8 minus 5. Okay, I'm going to do this on the side. 8 to the 2/3. That's 2 squared. That's 4. Over 10 times 3 over 3. 8 to the 1/3 is 2. Right, cubed root. Minus 9. Let's see. So that's 6 times 8 is 48. 48 minus 20. 30, these cancel. 5 minus 9. So that's 28 over negative 4. So negative 7 is our final answer. Whew. That one was kind of hard too. I mean, they're doable. They're just a lot of work. Okay. If e to the y equals tan x, All right, pause the video. Multiple choice, so make sure you got to figure out your answer. All right, derivative of e is itself, so e to the y dy dx equals secant squared of x. So we get dy dx equals secant squared of x over e to the y. Now notice there's only x's in this. So we have to look at our original problem, and e to the y equals tan x. How do we solve for y? So if we take the ln of both sides, oops, ln. So we get e to the y, that's really terrible, ln, oh, never mind, I lied, ignore me. What's e to the y equal to? I really overthought that. E to the y equals tan, so I can replace secant squared, not secant squared, I can replace e to the y with tan. Okay, still not done. Let's see, secant. All right, so let's see. Secant squared is 1 over cosine squared. And then tan is sine over cosine. So I'm going to flip it. Cosine x over sine x. So this cancels with this. Oh, it's a. So I have 1 over cosine times 1 over sine. Cosine is secant, sine is cosecant. So it's a. Yeah, you really need to know your reciprocals. All right, last one. We actually did this one in class. So try it again. Try it on your own. It's really not that bad. They gave you the first derivative, and they want you to find the second derivative. So remember that the derivative of the square root of x is 1 over the square root of x. And I always use that fact. That's why I have it memorized. So the second derivative, the derivative of that square root is over 2 root 1 minus 2y cubed. And then on the top, I'm going to put the derivative of the inside. Derivative of the inside is negative 6y squared dy dx. But dy dx is this. So we get, I'm going to simplify, negative 3y squared over that square root, 1 minus 2y cubed. And then I'm going to replace this with that square root. So the square roots just cancel out. B. Done. Looks scary. It's really not that bad. All right, there's your homework. Work on it. I will see you later. Bye.